Awesome. I might be, I don't know. Amazon Web Services? Cool. This is a good time to say, like, we paid for me to come up here, so I don't want you to think that I'm just sort of, this is an altruistic thing. I'm not going to make it too sales pitchy. I think everybody has, because I'm not a sales guy, I'm an engineer. Google's mission, I think everybody knows it, organize the world's information and make it universally accessible and useful. This has turned into 7 massive products, right? From Chrome to Gmail to Play, right? Massive applications. Those are our beachhead applications for our cloud. We have an internal private cloud. That's how most of you all have likely started your journey towards a sort of a true cloud environment. That's how our journey has unfolded. And now we're trying to make our journey sort of a template for the journey of others moving to cloud. And that journey started for most of us with, hey, let's deploy a bunch of boxes. I've been there, right? You go and you unpack it and you plug it in a data center someplace. But the key there, where we really started making this transition, is you don't own the physical property where you've plugged in your box. I remember my first Sun E4500 that I unpacked and plugged the CPUs in, and that was awesome. But that was a very expensive proposition. Even though I didn't have to build the cage and build the physical building that the cage is in, I still had to deal with the physical hardware. And when it got stale, obsolete, I had to replace it. I had to go find the next thing and plug that thing in. Okay, so what happens next? Virtualization. Go find somebody else to plug in the physical box. And then, am I going to annoy you if I walk around? Camera guy? Am I going to annoy you if I walk around? See, I'm such a nice guy. So let's find somebody else that will buy the hardware and then run something on it that lets me virtualize into it so that I don't have to deal with the mechanics of the physical hardware. And that was great. So now instead of me having to get a purchase order to buy a box, now I call an API to get a box, a virtual box. But they're still boxes, right? I've still got a machine. It's a virtual machine, but it's still a machine, right? The sort of the fundamental atoms of the application haven't really changed, right? I'm still gonna, I'm gonna run Oracle or MySQL or SQL Server, but now I'm gonna run it on a virtual thing. But I still have to run it and manage it, deal with it when it runs out of disk, figure out how to monitor it. That's still my problem. So where we're trying to go, and it's not unique to us, right? Our competitors, Amazon, of course, is the obvious notable one, Azure, are trying to make all of that notion of infrastructure go away. So you developers, and I presume, who identifies as a developer? Cool. I think the only right answer in the world today to that is yes. We want you, developers, to be able to focus on developing, right? Delivering value to your business and not managing infrastructure. Whether it's physical or virtual, doesn't matter. We don't want you to have to deal with it. So you can just focus on your applications. See, this is why I wanted, that's that slide. We're serious about this. So this is a point that we often kind of get asked. Google has a little bit of a, who remembers Reader, right? And everyone looks angry when I say that. We had something of a reputation of putting out a product and not really sticking behind it. Search being the notable example, Chrome, certainly Android. We're serious about cloud. We spent close to $30 billion over the last 3 years in CapEx investment in our cloud platform. So we are serious. When I started at Google 4.5, almost 5 years ago, we didn't have a cloud platform. Now we're to have a seat at the table. We're sort of credible competitors. And one of the big reasons that we are credible competitors is this, which is our network. And Google's network is really remarkably cool. And I'm not a networking guy. It's one of the things that I've never really been able to wrap my head around in a deep way. So it seems like magic to me, which is kind of awesome. But we have physical points of presence for Google itself effectively everywhere in the world. So when you're traveling in Vietnam and you open Google on your phone, your TCP connection is being terminated very close to you. I don't know where exactly, but very close to you. And we're backhauling that connection to a data center as close as possible to where you are, which makes it very efficient, very, very high performance. We've taken that experience and mapped it into our cloud offering. So when you are running an application in Google Cloud, it's running on the same physical substrate, the same data centers, the same underlying infrastructure, the same network as Google itself runs on, as search and ads and Gmail run on. And that's where we think we have something special to offer to customers. Excuse me. So digging into that a little bit, our infrastructure itself is really cool. I don't know if folks have read this paper about Borg, which is our cluster management system, large scale. It runs our many, I can't say, we're only allowed to say we have more than 7 computers across the world. That sits on top of, for cloud, very fast, as best as we can do, virtual machines with great interconnects, sitting on top of very fast storage, run very reliably by our site reliability engineering organization. We have representation of that organization in the room, Liz. I think Liz gave I know Liz gave a talk earlier that was related. So Google SRE is also kind of a magical thing. It really is not just it truly is not an operations function. It is an engineering function that helps us run systems exceptionally reliably. And we bring that to cloud because it's that same spirit and culture and practice that is running the cloud platform. We're also working on bringing that expertise to our customers so that they can run their applications using the same principles, practices, and tools that we use to run Google applications internally. That's part of what my team is responsible for. We're also working hard, and I'm not a pricing expert. I find it a very complex thing. We are working to make it simple. For example, by using sort of sustained use discounts. GCE sustained use discounts is actually really neat. Unlike on, I don't want to bash Amazon because they're awesome, but unlike Amazon where you have to do a so-called reserved instance purchase to get the lowest price, on Google you just run. And we will apply the discounts as though you had committed up front. So we think that it's not fundamentally about competition, it's about making it easy, right? Making it simple for our customers. And then I talked about geography already. We have already 11 new regions this year and next planned and in place. And each of our regions, of course, is high availability, multi-zone, which you would expect from us. We're also working really hard to meet the needs of our enterprise customers. So this is a population that Google fundamentally really in our DNA coming into cloud, we didn't know anything about, right? Google wasn't about how do you service a big bank or a big retailer or a pharmaceutical company, right? That wasn't in our DNA. We've learned. So we're working really hard now to understand the needs of our large enterprise customers. We've established an office of the CTO. We hired Diane Green, who was had been the CEO of VMware, who is an enterprise expert, and have really established all of the necessary functions from the way we do documentation through the way we do professional services, the way we do support, to really sort of connect with the enterprise customer. I'm not saying we're there. I think we have still a lot of work to do, but it has really been a focus. And that comes from a ton of functionality, from granular access control, making it easy to lift and shift applications, running on-prem, moving them to cloud, providing tools to help do that. Interesting things like providing really great support for open source stacks, right? Enterprises today will generally have a deep investment in a variety of open source tools and systems. We want to make it really easy to bring those to Google Cloud. Either run them yourselves, we'll give you tools to do that, or use a managed version that we provide for you, like a managed SQL, which is Cloud SQL, a managed Hadoop, which is Dataproc. I'm hopefully going to leave, I know I'm going to leave time for questions, so I hope there are some. Security. So this is a place where I think Google can be really proud. Like, we are getting attacked, as you might expect, continuously from everywhere. We have taken the expertise that we've built up in security and turned it into a value proposition for Google Cloud. So if you were looking at public cloud 3-4 years ago, security was likely the reason that you didn't do it, right? It was likely the reason that you, CTO of your company or CEO, when your board said, hey, you need a cloud strategy, you fell back on this thing called hybrid, and you said, hey, I'm going to do hybrid, and hybrid kind of got them off your back, but what you really meant was you're going to put something sort of experimental in cloud and keep your stuff safe because you didn't trust the public cloud. We see that changing very dramatically. So what we're trying to do is take all of the expertise, and not just human expertise, but the systematized, implemented practices that we have in our network, in our low-level infrastructure, to make security sort of a simple checkbox. When you come to Google Cloud, you can count on it to be secure. So that is something I think we're naturally very proud of. Then we have the data angle. So Google, as you would expect, lots of data. Lots of data that we're very careful with. I'll be very clear about that. We take privacy very seriously. But the mass volume of data that we deal with as a company has given us an enormous amount of capability in tools and systems to manage, manipulate, analyze, learn over that data. So we're trying to take that expertise and turn it into products that customers can use through the Google Cloud Platform. So this is everything from analytics platforms like BigQuery, managed Hadoop and Spark. I mentioned Dataproc before. And now cloud machine learning, taking the expertise that we've built up in the learning space, like how do you identify spam and content that's in violation of some terms of service on YouTube, all the stuff we learned to do that, and making it available to our cloud platform customers. And then I already mentioned pricing. This is part of trying to make our cloud friendly. I don't know, can a cloud be friendly? I'm not going to get too far along that path, but we're trying to do our best. And part of that is trying to take the engineers that work on Google Cloud and connecting them with our customers so that it is an engineer-to-engineer engagement. And I think that has also given us a great perspective. And then the last thing I'm going to talk about, which kind of leads into the rest, is this notion of an open multi-cloud environment. And this is really a very intentional direction from us at Google to make lock-in not a thing, right? To make it possible to come to Google Cloud and not feel like you're trapped, that you don't have options, that you don't have a path to a hybrid multi-cloud story. So this is something that we've been working really hard on. And it comes from, in large part, a really fundamental kind of part of our DNA, which is how we've participated in open source for a really long time. So there's a bunch of icons here, from Linux to Python to Git to LLVM, places where projects to which we, Google, have contributed for a really long time and have significant contributions. So we 287,000 commits to open source on GitHub since 2016, 15,000 plus projects contributed since 2016, et cetera. So lots of places where we are trying to give back, right? Trying to play a role in the broader community, right? Not just hold what we have within, but also give it to the rest of the world. Historically, if you read the Google File System paper, or the MapReduce paper, or the Spanner paper, Spanner's different, let me leave that one off. Let's just use those two. Let's say you read the Bigtable paper and the GFS paper, and the MapReduce paper. What did you have to do if you were at the beginning? You have to go implement it yourself. Read the paper, try to understand it, and then go implement, what do you know? Hadoop. MapReduce turned into Hadoop. Bigtable, HBase. GFS, HDFS. Right? Somebody had to re-implement it all, and maybe you were just, okay, you can just pick up Hadoop. But that's a lot of energy that went into replicating something that we already had internally at Google. I mentioned Spanner. So this is the beginning of a shift. I'm going to talk about two more important examples in a second, where not only did we write the Spanner paper, but we also published, we made available Spanner as a service. That's Cloud Spanner. So this is a movement from us to make more of the capabilities that we use internally directly available, rather than requiring the ecosystem, the community, to rebuild these things in a way that, that is unnecessary. But there are two really notable, interesting, impactful examples of where we have taken this a step further, and that's Kubernetes and TensorFlow. So Kubernetes, have folks know Kubernetes? Hands up. TensorFlow? Some hands go up, some hands go down. So Kubernetes is our container orchestration system, lives on Docker. We have a hosted version of it called Google Container Engine. It runs on-prem, it runs on your favorite cloud. We have put an enormous amount of energy behind Kubernetes, and we think that it is really dramatically changing the container ecosystem. Its uptake is extremely fast. It is the #1 highest engagement project on GitHub. And we see it, again, being used by folks on-prem as a way to do hybrid on-prem cloud, as a way to do multi-cloud, and we think that's awesome. Having been in the containers kind of space for many years at Google, this was a natural kind of evolution for us. I mentioned Borg before. Kubernetes was built by many of the same principles that built and ran and evolved Borg. It's a lot better in many ways, Kubernetes. Borg has become very, very, very complicated. And Kubernetes takes the lessons that we've learned there and brings it to the open source community. TensorFlow is our same story, but machine learning instead of machine management, right? So it's our way to let sort of our machine learning expertise get out into the world, and it has been layered on top of and tools built around it and hosted versions of it, and that's exactly what we want to see. We want to see the community at large, the open source community at large, really embrace these things and extend them. So what this leads into is the way that we're trying to build for a world that we know will be multi-cloud. We can't presume, we won't presume that we will go to any one customer and expect them to only run on Google Cloud. We will always expect them to have some on-prem footprint perhaps, some private cloud, some other cloud, one of our competitors. We know that. So what we're trying to do is build tools that make Google Cloud a natural part of a multi-cloud, hybrid cloud ecosystem. And Kubernetes, that I already talked about, is a notable example of doing that. You can deploy to multiple clouds using the same underlying platform. I'm not so naive as to having been around the block a couple times, to believe that there's zero effort here, right? Oh, I built for Kubernetes. I ran it on-prem. I don't have to do any more work, right, to run it on Google. No, that's not true. But the work that you have to do is very predictable, and it is not in the core of your application. So risk is reduced. You have a very predictable way to get to another environment. Another example that I don't actually explicitly have a slide for is Spinnaker. So folks heard about Spinnaker? Spinnaker is our CI/CD platform tool for cloud, and it was built in partnership with Netflix, and it natively supports both AWS and GCP. So another very similar example, and it's of course open source. We have the manager emeritus of the Spinnaker team in the room, in fact. All of this leads into how we're trying to make, again, the Google Cloud Platform, open but rich, offering a wide spectrum of capabilities to help you build applications on Google Cloud. From Compute Engine, so this is where we're back to, hey, remember the story of I had the physical box, now I've got the virtualized box, but it's still a box. Compute Engine is still a box, right? You still have to think about infrastructure, you have to think about VMs. Then you go to Container Engine, which is our, again, hosted version of Kubernetes. Now you don't have to set up a Kubernetes cluster. You don't have to think about the physical nodes underneath it. You just have to think about your application deployed as containers. But you're still thinking about, okay, I've got to package up this container, and I've got to know what cluster to deploy it to and what its dependencies are, wire them up correctly. Then you've got App Engine, which is platform as a service. You just give us your code, we run it. Quite famously, Snapchat grew from 0 to enormous on App Engine. I'm not saying that didn't induce pain on a variety of fronts, but they didn't change their application to go from 0 to massive. Now, of course, as you move through this spectrum from today, at least, as you move through this spectrum from the virtualized node to containers to PaaS, of course, constraints get applied. So that means that not every application is going to smoothly move through this spectrum. And that's where we're trying to offer a variety of alternatives that can meet a vast spectrum of needs. That leads us to Apogee. Apogee is a relatively recent acquisition for Google, which is about bridging from legacy APIs, legacy services, into an API-managed world. So that adds another layer of abstraction, the API layer. And then Firebase, which is the rich, flexible way to build mobile applications natively against Google Cloud. And then finally, trying to tie all these pieces together is Stackdriver, which is the product that my team is responsible for, which is attempting to be an integrated solution for monitoring, logging, diagnostics, making it really easy for our customers to run their applications reliably in an appropriately performant way at the right utilization on Google Cloud Platform and on Amazon. So we are trying to achieve a true hybrid multi-cloud vision. So we have pieces for monitoring and logging and so forth. I won't go into them in a ton of detail, because what I really want to talk about is how the story here is really about observability and not about, hey, here's a product. Go use our monitoring product and it'll be good. What we're really trying to do is offer an integrated suite that works well with a variety of other tools. And this is kind of what we're calling a signals platform. We use the term signals to refer to the sort of generality of metrics and logs and traces and debug snapshots and context graphs, right? All of the different ways that you can look at your application. You've all probably heard how does it go? 5 blind men, elephant. They look at it from different perspectives, and the guy that touches the trunk thinks it's a snake, and the guy that touches the leg thinks it's the tree, and the guy that touches the tail. So that's how systems are. You can't look at them through one lens and expect to see a whole. So that really informs our philosophy of building this so-called signals platform. So you see all the signals coming in from the left, and then what we do is apply a bunch of sort of augmentations, enrichments to the data, from identifying anomalies to just simply computing alerts, computing health. But more importantly is the right-hand side of this, which is externalizing all this data in a way that our customers can access it. So this becomes not just a single pipe that we build, we funnel the data in one end and we funnel it out the other end onto a dashboard, but instead it is a facility for customers to actually inject their data on one end, apply their own analyses, extract the data on the other end, apply different integrations of it. So we're really striving to make this a very open thing. And yeah, we have a commercial product on top of it, but that's not the whole story. We're working on really an ecosystem play here. And we're importantly working on 2 open source and open standards initiatives. One is Open Census, which is an open tracing initiative, and Open Metrics, which is an open metrics initiative, working with the Cloud Native Computing Foundation. So wrapping up, all of this at the end of the day, all the sort of stuff about observability is really about helping our customers run their applications reliably. We wrote a book on this. Has folks read the Google SRE book? It's pretty cool. It's got a lot of great insight in it. What we're trying to do is make the practices that are represented there democratized, available to everyone in a way that is just turnkey. So again, wrapping up, we're trying to be a good partner, right? We're trying to sort of tick the boxes that make Google Cloud different, open, simple, big investment from us, so we're certainly committed, with a big commitment to open standards. So that's the sort of the nutshell, and with that I will stop talking with a nice shot of New York from the sky. Questions? I hope there's somebody has a question. Again, I was cognizant that I sat between you and, yeah, Nick.
If someone wants to move their application they have in-house to something like Google Cloud Platform or something.
Yeah.
You mentioned you had one slide we touched on it that you have on this.
Yeah. Yeah, I'll repeat it.
What's the process?
Sure. I will transparently admit to not being an expert in what our lift and shift offer has, but it says here free VM migration service. Sounds cool. I guess I should know what's on my slides before Liz has an answer. So the question was, if I have an on-prem thing and I want to move it to cloud, Google Cloud, what have you got to offer me? And Liz knows.
Yeah, I can answer that. Is this microphone on? If not, I'll talk into this. How about I talk into this?
There we go. This is a non-company.
Okay, cool. So depending on the complexity of the workload, if you have a very sophisticated workload, we have a partner solutions organization that works directly with you to help you lift and shift your workload and design what is this solution, what is this going to look like on GCP. And my team focuses on customers that have very large reliability needs of how do we get you onto GCP and make sure that we're on the same page about what does reliability mean, how do we make sure that your application is going to reliably work on GCP. So that's kind of the extent to which we help you, both through partner solutions, through self-service tools, and through the customer reliability engineering team.
Awesome. Thank you, Liz. And if you want to follow up, we can make sure you're connected with the right folks to get the details. Yeah. But it did. Yeah, so what's the deal with New Relic? We're partners, and like that doesn't mean that we don't have areas where we have competing offerings. That's that's the nature of the world, and that's why I try to focus on Google Cloud and not so much on the places where we might have duplicative offerings with New Relic. But we do work together, and we have many mutual customers, and we find that in the customers that we share, they're using a combination of solutions. So what we're trying to do is make this just work well for both Google Cloud and for New Relic. And New Relic is a native solution in our cloud marketplace, so it's a fundamental partner for us. And yeah, it was a sales pitch because it's great. Other questions?
No other questions.
No other questions. Well, thank you very much for your attention. I appreciate it. You could have walked out if it was too sales pitchy, so thank you for staying, and enjoy the rest of your day.